In the interest of time, we're going to move on to our next speaker, who is Caleb Fassett, who will be briefly introducing the DSNE document. Take it away, Caleb.
So can you hear me? I lost audio for a second.
Yes.
Okay. So I'm here because the organizers asked me to talk about this document, the design spec for natural environments, or nicely called the DSNE. And it's a document that's held in the environments group at Marshall Space Flight Center where I work. So there's a group called the HLS National Environments Working Group that basically meets on a regular basis and is trying to manage the environments for HLS and other programs. So next slide, please. So the DSNE is a SLS spec. That seems like an odd thing, perhaps, but it's actually held against a lot of programs in the agency. So in particular for us, it's probably most interesting that it is going to be levied against the HLS lander itself and also the new suit. And if you look at the list of environments that are described in the DSNE, it includes a lot of things that aren't lunar specific, so environments related to the Earth. But if you go to the next slide, I'll point you to the section 3.4 of the DSNE. I should also say that you can download this at the NTRS, so with the link after this meeting if you want. The other thing I'll mention is that we're actually hoping to have a revision of this, revision H, come out very shortly. It's not out yet, but pull it up soon. So next slide, please. So what are the lunar surface properties we have in this document? Well, it's basically sort of the boundary conditions that you expect spacecraft designers and instrument designers and suit designers to have to think about. And so there's things like topography, slopes, craters in a general way. And we also point to the data that you can use for site-specific analyses. And we note in the DSNE that for any specific mission, you really want to go and pull that site-specific analysis for yourself. I will then point specifically in the next few slides to actually more regolith-related topics, rocks and regoliths. If you go to the next slide, please. Yeah, so the kind of thing that we include are things like the rock distribution on the surface, and obviously the reason this is important is for things like operations and safe landing. We put in the diviner data from Paul Haynes' paper that shows, the vast majority of the lunar surface has less than 0.5% fractional area covered by rocks, and also some of the more classic data from Surveyor and other missions that you can turn into a power law and make a prediction for how many particles at various sizes are available. And the key thing, a key mention here is that the DSNE tables in this document are the design environment. It's not the figures. There's a lot of nice science figures in here, but those are mostly used for reference. And also, again, I just reiterate that for site characterization, you really got to do this in a specific location directly. So next slide, please. So that was the rocks. We also have the size distribution of the regolith in here. One of the things I found striking when I got involved in this effort was actually how frequently the same sort of size distribution was seen at the Apollo sites. And so Carrier 2003 pulled out a sort of all Apollo reference curve, and the middle blue curve of these three is the median, and that's actually put in a table in the DSNE that you can use as sort of the reference guide for what the particle size distribution that we would expect the regolith to be on the moon is. And we can talk later in this meeting about how likely that is to apply to the pole and other places, but I think that's for the Apollo sites anyway, we have a really pretty good sense of the data. Next slide, please. And of course, the finer fraction is more open, as Joel already alluded to. The particle size distribution of dust has only been measured a few times. And so we have a table for these in the DSNE, but obviously more measurements would be better. So that's something to think about. One of the revisions in Rev H is actually an update on how dust, where the finest fraction of the particles behave based on lattice. Next slide, please. And so probably if you go into this document, you'll see this table 3.4.2.3-1 and be like, okay, well, all this stuff just looks straight out of the lunar source book. And the answer is, yeah, that's right. That's really the best data for many of the physical properties of the moon. It hasn't changed. We went and looked at lots of literature for trying to update this and decided, really the data that Apollo gathered is the gold standard right now. And so these are in the DSNE. These are what you should design against. And so, that's the current best estimate for these objects, for these parameters on the moon. Next slide. So the final point I'll make in this last slide is basically that the Disney is an official spec, and that basically means it doesn't want to move very fast because it's written into the contract for programs. And so we want to get the environments right for the moon for designers, but it's not that easy to change. I know Rob Suggs is on here, and if you want to, if you have any concerns or comments about what's in the Disney, Rob's the sort of the holder of the book for this, or you can contact him or you can contact me, and we can discuss what issues you have if you have some for this document. Thanks.
Thank you, Caleb. And I do notice that Rob put the link to the Disney in the chat and in the Q&A, so folks can get to it there.